So let us start the subject, which is design and analysis of algorithms. Okay. So before starting the subject, we should know why we are studying this subject. Now, if you have studied some of the programming languages like C, Java, .NET or any other programming languages, then you should know that when you are studying these programming languages, then you are studying the syntax of these programming languages and how you can program in these specific programming languages, right? And their features. When you are studying data structures means you are adding some more new data types to these programming languages. For example, we have some primitive data types which are integer, character, floats, and now when we are studying data structuring or data structures, that means we are adding new data types to enhance the power of these programming languages. Enhance means that means you will be having more capabilities, right? But when I am studying design and analysis of algorithms, means you are going to design the algorithms and you are going to analyze these algorithms on the basis of some criteria. Okay, and designing means, see, if you are studying programming language, that means you are studying the syntax, but how to program, that is given by the algorithm subject. How to program, what are the different programming techniques, we are going to study these programming techniques into the subject which is design and analysis of algorithms. Here we will be more focusing on programming techniques like dynamic programming. What is dynamic programming? What is greedy programming? And then how can we use the power of this dynamic programming or the concept of the dynamic programming to solve real world problems. Okay, so that is your subject, which is design and analysis of algorithms. Fine, but let me write the name of the subject. Name of the subject is design and analysis of algorithms. We have design and analysis of algorithms. Now, algorithm means, what is an algorithm? Algorithm means we are going to define some sequence of steps which will be a finite sequence to solve a problem. Okay, we can say algorithm means it is a finite sequence of steps to solve a problem. Okay, now this finite sequence of steps does not necessarily mean then these algorithms can only be applied on computers. You can give algorithms to solve different mathematical problems. You can give algorithms to, say, let us suppose you are designing a robot or you are designing a machine, self-automated machine, which is going to make a cup of coffee for you. Then to that machine you have to specify what are the specific steps which it should take to solve the problem. This problem may be creating a cup of coffee, right? The problem may be go to kitchen, bring some water, something, anything, right? So if you have any problem and you can formalize some finite steps to solve that problem, that steps will be called as algorithms, which we specifically call as algos. Okay, and here designing means we are going to design those algorithms, right? And here analysis means we are going to analyze those algorithms on the basis of some kind of criteria. Okay, now what does it mean when I say analyzing those algorithms? It means, let us suppose you have a problem. Some problem. Okay, now to solve this problem, you can write a program. To solve this problem, you can write a program, or you can give an algorithm which is going to tell you what are the finite steps you should take to solve this problem. Okay, but the thing is, it does not necessarily mean when you are writing a program or designing an algorithm that you are going to have only one program or only one algorithm. To solve one problem, you may be having more than one different types of programs, or you can propose more than one different algorithms, right? So what I can say is, let us suppose to solve this problem, I have an algorithm A1. To solve this problem, I have an algorithm A2. To solve this problem, I have an algorithm A3. And to solve this problem, I have some algorithm, let us suppose it is AN. We have some algorithms. But now the question arises, if to solve these problems, you have some algorithms. Now out of these algorithms, which algorithm is best or which algorithm is better as compared to other one? Okay, now let us say if we have algorithm A1 to solve the problem and algorithm A2 to solve the problem. Now out of these two algorithms, which algorithm is better and which algorithm is going to solve this problem more effectively, right? So we may be having different kind of criterias by which we are going to analyze these algorithms, right? So we can have different type of criteria. For example, let us suppose we create a program to find the factorial of a number. Now if we create a program to find the factorial of a number, you can write infinite number of different programs to find it, to find the factorial, right? Now let me just take two small examples. I'll take an example of a non-recursive programming, and I will take an example for a recursive function. You can give any variable to these functions, and then out of these two programs, you have to identify which one of these program is better, right? So what I can do is, let us suppose we want to find the factorial of a number. So the first function is factorial of a number, which is going to return the integer variable, and it is going to take the variable n for which you want to find the factorial. Okay, now what you can do is, let us suppose I am taking one more variable, int facto, okay, which is equal to, let us suppose, 1. Int facto is equal to 1. Now I can do for I is equal to, or you can say for int I is equal to 1, I less than n I plus plus, less than equal to n I plus plus, and then we can do facto is equal to facto multiplied by I. Okay, this is the first program, and then we are going to return facto. Okay, so this is a very simple non-recursive program to find the factorial of a number. We are just using a for loop to find this, right? And we can write a recursive program also. Now let us say we have the program which is int fact for int n. Now if n is equal to 1, or you can say if n is less than equal to 1, then return 1, else return fact of n minus 1 into n. So this is a recursive program, right? So see, I have proposed two different solutions to solve one problem, and the problem was to find the factorial of a number. Okay. Now out of these two programs, what do you think? Which program is better? How you are going to analyze out of these two programs which program is better? Okay. Now you can say, sir, we are going to propose different metrics to tell you which program is better. Okay, sir, propose some metrics. Okay. Then one student says, sir, if out of these two programs, this program is very easy to understand, therefore this program is better. You can create your own metrics, right? So what you can say, let us say if we have two programs and I want to know which program is better, then you can say, sir, a program which is easier to understand, that program is better. Okay, I say okay. Any other thing? Then other student stands up and other student says, sir, out of these two programs, this program is taking less number of lines, you can write this program into one single line. Therefore, this program is better than this program because this program is taking more number of lines of code. That means you are analyzing these programs on the basis of lines of code, right? Then you can say, one more student stands up and says, sir, I am saying that this program is more beautiful as compared to this program. Therefore, this program is better. Okay, I say, let us suppose which program is more beautiful. Then one more student says, from the last bench, he says, sir, out of these two programs, if I execute these programs, if one of these programs is going to take less amount of time to solve the problem, that program is better than the other program. Then he says, sir, we are talking about which program is going to take less amount of time to execute. That means which program going to take less time to execute. Whatever program is going to take less time to execute, that program is better as compared to the other program. Okay. Now one more student says, sir, out of these two programs, we say one of these programs is taking less lines of code, but we did not see which of these programs is taking less amount of space. Because when I am saying less amount of space and less number of lines of code, both are different things. When I am saying less amount of space, that means when you are going to execute this program, then these two programs may need different amount of space while executing. It may be because of recursive calls onto the stack, or it may be some constant space in this case, right? So that means whatever program is going to take less amount of space. Okay. Now you can propose more number of matrices like this, right? Or you can say, sir, who have written this program, mine program is better than so on. You can propose different types of matrices here. But out of these matrices, what do you think? Which matrix is the most effective one? Which matrix is going to tell you which one of these two programs is better? For that purpose, we use something called as this, which is called as the time complexity of the program. Which is called as the time complexity of the program, and this, which is called as the space complexity of the program. We have time complexity and the space complexity. Okay. Now when I am saying time complexity, see, less time to execute, that means which program out of these two programs, which program is having less time complexity, and out of these two programs, whatever going to take less amount of space, that will be the space complexity. These two are our primary matrices, are our primary measures to check which one of these programs is better. Now when you have done these two comparisons, then after that you can go for any of these comparisons. For example, you will say, sir, the next matrix can be less lines of code, the next matrix can be easier to understand, the next matrix can be beautiful, and so on, right? So you can make your own matrices. But when I am saying which one of this program is better, then I will compare on the basis of the time complexity and the space complexity. Okay. Now what is the time complexity? How can you say a program is better than the other program on the basis of time complexity? Okay. That means let us do one thing. Let us say that we have a CPU here, we have a computer here, we build our home computer. This is, I don't know how to draw this, but let us say we have a computer here. I don't know how to draw this, but let us say this is the computer. Okay. And this complete is the program P1, and this complete is the program P2. Okay. Now I am saying this is my server side, or this is my system, and I am executing this program P1, and we are also executing the program P2. First I executed the program P1, and let us say the program P1 took 0.49 millisecond to execute, and then I have executed the program P2, and let us say it is going to take 0.73 milliseconds to execute. Okay, that means we are basically working on the physical execution times of the program. That means if I am executing this, then on real time on my system, which program is going to take less amount of time. Okay, but there are some issues with it. Now, what is the issue? Let us say we have a client. This is a client, and this is you. You are a developer or a programmer, and he's some let us say he's having a company or a shop or something. Now he says, I want you to develop a program for me for my business, which is going to give me information about 10 products or 10 items for some sake. Let us suppose he says that, sir, my company is going to deliver some online goods, or I'm creating some website. So let us say we are creating some dating website. He wants to create a dating website. Now on the dating website, he wants to say, let us say, sir, I want that in 1 minute or in 1 second, a person should be able to view the list of 100 males or females around his area. Male or females or around his area. Now, out of this 100 females, he says, sir, please write a program for me. And you are very proud that you got a project and you are writing this program. Now, let us say you are writing this program. You have done the program, and on your system, it is giving you a list of 110 males or females around the area. And now you deliver this program to your client. And on client's machine, this program is going to say deliver somewhere around the list of 80 males or females around the area. Then your client says, sir, on my system this program is not behaving better. This program is only giving a list of 80 person around the area, but I wanted 100 males. Then he gives the program back to you and says, please improve the program. Now you have done your best and you have improved the program. Now your program is going to give you a list of 120 people around the area. Then he deliver this program to the client, and in the client machine this program is only going to deliver around 85 people around the area. Right? Now see, you have done the program in a better way. You have done your best. You have delivered the program to the company or the client. Now the client is complaining that I wanted a program to deliver me at least 100 males or females, but on my system this program is going to give only 80 to 85. Now you say, sir, my system is a very high-end machine. I am using a very high-end system which is created for developing, but you are using a very outdated system which is very slow, and on your system this program does not behaving correctly. Now he says, okay, let me do one thing. Let me buy a new machine and let me test the program. Now he buys a new machine, and then on his new machine this program is, let us suppose, giving list of 95 people within next 1 or 20 next minute or within next second. Now he says, still I'm not able to get this much data which you are promising me. Now you are thinking that what can be the reason why you are not why the client is not getting this thing, right? So the reason can be the machine which the programmer is using, the machine or the computer which the programmer is using, it may be high end, and the machine which the client is using, that may also be high end. But now what can be the reason why it is not giving you a better output here? In both these cases, this can be because of the reason that the machines which you are using and your client is using, both these machines may be having different computer architectures, different CPU architectures. Now what does it mean? What does that mean is that, for example, let us suppose you are having, whenever you are going to execute this program and you are giving this program to your compiler, then the compiler is going to convert this, going to give you assembly code, right? Let us suppose we have some random assembly code which is add R0, R1, subtract R2, R0, jump if non-zero to instruction, let us suppose line 1 or jump it 0 or whatever, you have some instructions here. You may be having a multiplication instruction, right? Now if you are saying addition instruction, now if you are having two different CPU processors which are having different architectures, let us suppose we have the CPU 1 and we have the CPU 2. Now these two machines are having different architectures. This addition instruction may take 2 clock cycles on this CPU to execute. This addition instruction may take 3 clock cycles on this machine to execute. This jump instruction may take 3 clock cycle on this machine to execute. This jump instruction may take, let us suppose, 2 or 1 clock cycle on this machine to execute. That means, see, I am not taking these values actually exactly. I am just assuming that these instructions are taking different clock cycles. In practical, they also take different clock cycles because of the CPU architectures, right? Now these instructions are taking different clock cycles to execute. Now if you execute a program which is having more addition instruction as compared to more jump instruction or subtraction instruction, then this program will run faster on this machine, and the other program which is having less addition instruction or which is having less addition instruction but maybe more jump instruction, jump if no zero instruction, then this program may run faster on this machine. That means the program may behave differently on different machines with the different CPU architectures. These instructions may take different time on different CPU architectures. Now how will you compare which program is better? Okay, so let me just draw this same thing in diagrammatically here. Okay, now let me tell you diagrammatically what I am saying. Let us say we have two CPUs. This is the CPU 1 and this is the CPU 2 or the machine 2, right? And we have two programs, the program P1 and the program P2, and both these programs are solving the same problem. Let us suppose this is a program P1 and this is a program P2, and both these programs are solving the same problem, right? Now I am saying the program P1 is running faster on CPU1 and it is running slower on CPU2 when you are comparing the actual running time, and the program P2 is running faster on CPU2 and the program P2 is running slower on CPU1. Now why they are behaving like this? Because as I already told, because these two CPUs may be having different CPU architectures. So one program may execute this instruction faster, these instructions which are included in this program faster, and other program may execute the recursive calls faster, let us suppose in some sense. So these programs will take different execution times on these different machines. Now you tell me, if you are going to compare these two programs on execution time, which one of these programs is better as compared to the other program? Think about it. What can be the metrics which you are going to use to tell whether which one of these programs is faster as compared to the other program, or which computer's program is going to take less amount of time, right? As you have seen, because we are basically dependent on the machine architecture. We are comparing these programs on their actual running time, right? So by this you should know that we cannot compare these programs on the basis of their actual machine running time or actual running time. Now you need a matrix to tell the person that this program is going to take less time on the basis of some criteria, and this criteria should be independent of actual running time, that means, or you can say independent of machine architecture. That means whatever criteria which you are going to use to compare these programs, then that criteria should be independent of your machine architecture. Does not matter on what machine you are going to run these programs. You should be independently able to compare two programs, not on the basis of actual running time. Okay, so you should be able to propose a matrix where you can compare those programs on the basis which should be independent of machine architecture. Now what can be that matrix? Let us see. Now when I am saying that this instruction is going to take 2 clock cycles here, this instruction is going to take some clock cycles here, this instruction, let us suppose it is taking 3 clock cycles here. Now these clock cycles are based on your actual CPU architecture. Now let us say if we have 2 machines and these clock cycles can be different on these 2 machines. Now instead of taking this, let me just see how many instructions we are going to execute. If I can say how many instructions which we are going to execute, then on that basis I can compare the programs. That means what I am saying is we are going to compare actual number of instructions which are being executed, instead of the actual running time of these instructions. Now what I am saying now, whenever, let us suppose we have some instructions, we have add R0, R1, we have subtract R2, R0 and R1 and so on. Now in all these instructions, I am not comparing, I am not calculating what is the actual running time of these instructions on the machines. I am saying this instruction, let us suppose it is going to take 1 unit time or 1 unit machine time. This instruction is also going to take 1 unit machine time. Now let me just count what are the number of instructions. Now if you are saying what are the number of instructions, then you can compare 2 programs. Which program is better? Okay. Now for that purposes, here we are ignoring these actual constant values, which is 2, 3, 4 and so on. This is the actual values, clock cycle values, which we are ignoring, and we are also ignoring what is the actual running time. We are just calculating what are the number of instructions which we are executing, and on the basis of number of instructions we can compare 2 programs, and we can say that which program is going to execute faster as compared to the other program. That will be our matrix to solve the problem. Okay. Now here let me give you some examples here. What I mean to say, and then let me introduce you to the new terminologies which we are going to say. Those new terminologies will be the asymptotic notations. Fine. Now let me write 2 programs here. So in the same way, let us say we have one program which is P1, which is saying we have a function, the main function. Now in the main function, what I am doing is I am saying printf hi, printf hi slash n something, printf hi, and so on. You are writing the same instruction up to, let us suppose, 20 times. You are printing hi 20 times. Okay, so this is the first program. There are how many lines of code? A part of this main function we have 20 lines of code. Okay. Now we have the other program which is this main function, which is saying for int I is equal to 0, I less than 20, I plus plus, and then we have printf hi. Fine. Now in these 2 programs, if you are saying in this program how many instructions are there in this program, let me count the instructions. We have, this is the instruction 1, this is the instruction 2, this is the instruction 3, up to so on. We have 20 instructions. That means we have 20 instructions. Okay. Now in this program we have the first instruction and the second instruction. That means we have 2 instructions to execute. What do you think? Which one of this program is executing less lines of code, or which one of this program is executing less number of statements? When I am saying you have to compare these 2 programs, now which one of these programs is executing less number of statements? Okay. Now in this, let us suppose every instruction is going to take 1 unit time. This is going to take 1 unit time. This is also going to take 1 unit time. This is also going to take 1 unit time. up to so on, all these instructions are going to take 1 unit time to execute. Let us say these instructions are going to take 20 unit times to execute. 20 unit time to execute. Okay. Now in this program, if you see this instruction, the first instruction, int I is equal to 0. How many times this instruction will be executed? This will be executed only once. Therefore, it is going to take 1 unit time to execute, because this instruction is executing only once. Now, the next instruction, I is less than 20. How many times this instruction will be executed? What do you think? So, this instruction will be executed how many times? First of all, when I is 0 to 19, when the value of I is 0, starting this is 0 to 19, so when the value of I is 0 to 19, this instruction will be true, right? That means till that time executed 20 times, and then when the value of I became 20, then this instruction will be false. Therefore, this instruction is executed up to so many times. How many times? 21 times. For 20 times this instruction was true, and at the 21st time this instruction became false. And how many times this instruction will be executed? This will be executed again 21 times. How many times this instruction will be executed? This will be executed again 20 times. Okay. Therefore, in total, how many times these instructions are executed? So 1 plus 21 plus 21 plus 20, which is equal to 1 plus 42 plus 20, which is equal to, let us say, it is 63 instructions are being executed. 63 instructions are being executed, and in this program only 20 instructions are being executed. Therefore, here it is going to take 63 unit of time, or you can say 63 units here. Just say, let us suppose it is saying 63 units to execute, unit time to execute. Okay. Now here, now as you can see, we have compared these two programs on the basis of number of instructions being executed. Now in this program, in the actual scenario, we have neglected some things. What are those things? Let us suppose we had this program add R0, R1 for every instruction. We have neglected that what is the actual clock cycles. Here it is saying that it is going to take 3 clock cycles to execute on first CPU and 2 clock cycles to execute on other CPU. That means we have executed these actual times, we have ignored these actual times, and instead of taking these actual times, we are taking 1 unit time, and here also taking 1 unit time. That means both the instructions are taking 1 unit of time. We have ignored the actual values. Again, here in this case, if this is going to take some constant time and this is going to take some constant time, then I am going to take as 1 unit time, and I am going to tell you how, and we can say this as 1 unit time, right? For this, I can just say, for simply saying it is as it is a constant number, because it was also a constant number, we made this constant number as 1. Here also it was a constant number, we made this constant number as 1. Therefore, in the same way, we can make this constant number as 1 unit time, again, which is a constant time. Again, here also I can say it is going to take some constant time. I am going to tell you how mathematically we can do this. Okay. Now, for these purposes, I have to ignore. I have to introduce one more terminology here, that is the asymptotic notations. Okay. Now, let us see what are the asymptotic notations and how we can compare two programs using the asymptotic notations. Right.